Let's look at another example for finding the inverse of a function algebraically. Again, I'll always encourage you to graph this first. Okay, so we have, let's go. We've got g of x equals, was it 3 minus 2x over 6? Is that right? 3 minus 2x over 6. Here's our function. It's linear, right? You may not think it's going to look like a line, but really each one of these numbers could be divided by 6. I don't want to get too far off track, but this is really the same as 3 over 6, which is 1/2, minus 2 over 6, which is 1/3 x. So that's why it technically also has a linear format and slope-intercept form like so. Okay, we don't have to dwell on that too much. Just look at the graph and say, yes, this graph passes the horizontal line test. If I draw a bunch of horizontal lines, I'm not going to hit this twice, right? So it passes the horizontal line test, therefore it has an inverse. Sorry about that. Come on now, here we go. So how do we find the inverse? We replace, in this case, it's g of x with y, so we put a y here. We have 3 minus 2x over 6, all right? And then we swap the x with the y's. So we have 3 minus 2y over 6. Now, when we're solving a rational equation like this and we want to solve for y, we can't get at either any variable that we're solving for that's in a fraction, like a rational expression like this. I can't get at it, okay, until I've gotten rid of this denominator. So the first thing that I have to do to get rid of that dividing by 6 is the inverse operation of division, which is multiplication. So we multiply both sides by 6. We have 6x equals 3 minus 2y. And then we can solve this a little bit easier now that there's no fraction. I'm going to subtract 3. Okay, I can't get at that negative 2 because it's attached to here, right? We talked about how the order of operations, right? Here's our order of operations. So the inverse order of operations goes in the opposite direction. So we start with addition and subtraction if we can. We couldn't do that right away because we had this 6. So like I said, in this case, we had to multiply first because I had to get at this numerator. I couldn't get at this numerator until that 6 was gone. Now when I look at what I have to do here, I have to subtract the 3 first, which is the first inverse operation on my list. So I have 6x minus 3 equals, when I get rid of this 3, there's a negative 2y here, but that negative 2y is being multiplied by, that negative 2 is being multiplied by y, so I divide. And I divide everything over here by negative 2. So we end up with 6x minus 3 over negative 2, which is equal to y, which is our inverse function. Okay, and again, check the operations. Multiplication by 6, the addition of 3, and timesing by negative 2. Now we're dividing by negative 2, subtracting 3, and multiplying by 6. So all of our inverse operations are down here. Check.